Welcome back. This one is going to be a really funky tutorial. I'm going to do a very quick mix here. This is that wonderful hip-hop track by Tim Shroom, and I'm going to only concentrate on one segment. So let me just drag this up. So just about 16 bars here. There's other bits and pieces playing, so I'll switch all that lot on. And I think, yep, we got a bass there as well. And we've got, I'll bring, let's look at the hooks. Yep, hook here, and here, and here. What the hell is this? Delay hook? No, that's part of the vocal vibe. Right. What I would like to do now is run in here and switch off what I don't need. Don't need that. Don't need those. Leave those out. I'm running through this really fast. Oh, glide bass. Okay, I randomly picked a whole bunch of sounds that I think are going to just afford us a little bit of variety. I could do this all on my own and come back to you, but I think it's important that we do this together and you watch my workflow. And what we'll do now is run a quick mix to noise. I've got a whole video dedicated to mixing with noise, but I'm going to run through this really quickly with you. Faders up mix, which we've covered in, oh God, two, 3 videos already. This is the insert for my master bus. I've arranged it like this so you can see the metering in the middle, the ppm meter here. In other words, I'm going to calibrate all of these together, including the BX meter, the loudness meter, the VUMT duo, when the time comes for that, the digital scale here, which we're going to drop into K14 later, the AES 17, which adds the 3 dB on our RMS value, so we get the RMS and peak calibrated to 0, and I've left all the faders at 0. This is called fader up mixing. In other words, we do all our gain structuring at the insert points, or if you are lucky enough to have Cubase, you'll have a channel strip with a pre-trim. Take note, DAW manufacturers, think channel strip. Give us everything on the damn channel strip. If you haven't got that, then you're going to have to use some kind of utility. In Logic, I think you've got the gainer plugin. I will use the VUMT on every channel or any of these meters that has a trim knob. Okay, so first things first. Let's not worry about the test tone. Let's look at all our meters and make sure everything is reading what it's meant to read. Right, what I'm doing now is playing you this segment. You'll see that there's other bits that come in, bits that are quiet. You'll get all these interchanges in between all the different parts. I haven't included any of the others because I want to keep it simple and fast. But we'll come to these in the technique section of the videos. First things first, this is our loudness meter, the tone boosters one, which I absolutely love. And I'm going to use this a lot. This and the LUFS are going to be my 2 main meters I'm going to use in terms of the loudness meters. Let's now have a quick look at what everything is reading and try and correlate everything to each other. And to do that, instead of running all the audio, let's run the test tone and put it on sine. Okay, and now we can test to make sure we get all the right values everywhere. What I want you to look at is -20 here. This should say -23, and you know that if I flick this switch in, that should drop down to 20. There. So we've calibrated these two to 0, -20, -20. -19.2 on our true peak meter, because remember, this is an average across the program integration time. I let this play for about 8 bars or so. I could have let it go for 16. And it calculates and gives me the loudness measurements that I need and explain to you from the last video tutorial. Integrated loudness -20, I expected to see that. Loudness range is 0 at the moment because we don't really have any dynamic movement here. Nothing. Look.
And true peak minus 19.2, fair juice. LUFS EBU 128, my standard settings, everything is now calibrated. So what do I want to do? Well, I want to use the noise function out of this, but what I am going to do is not calibrate the channel yet. So I'll switch this on and drag this on pink to minus 20. And I've done this for a reason. I'm actually giving 20 dB of headroom. Bear in mind, we're currently working in digital. I'm working using PPM meters. It's only here that I'm bothered with true peaks. It's just really to show you how all of it ties up together. Again, all the information we need is pretty much accurate. It's our dynamic range, and because it's noise, it's never going to be constant, so you're going to get fluctuations across all the material. And these are our new readings. True peak minus 20, minus 20, minus 20, minus 20. Okay, what am I measuring now? Well, I can't measure the test tone if it's on the master bus in terms of program integration. This needs to be music. But because we want to mix to noise, we're using the pink noise function from the MDA test tone. Let me switch that off for a second and show you what happens if we're actually going to measure. Let me get rid of these two because we don't actually need them for now. And let me put this here, and this time I'll reset this and play for the program loudness. And then we'll watch the values it gives here, because it's going to be far more accurate than running a pink noise generator. Remember, this is all very loud. You can see that we're slamming already into the ceiling because we haven't mixed anything. I'm just trying to find my target loudness values based on what I'm hearing here. Minus 15 is not good enough for me. Remember, I've got lots of other tracks that are going to come into the mix later, and that's just going to shoot up. Bearing in mind I'm looking at minus 23 as my target, this integration isn't great. If I stop the music here, based on this 16 bars, this is the information we have. So the program integrated loudness is minus 14.6. My true peak is plus 0.4, so I'm already over. And my loudness range is 4 dB. It's just the dynamic range of what you just heard. I've now shown you how to calculate all your varying loudness values by recording your program integration. You select, it could be the entire song or a bunch of bars. You select it. It's up to you. Now let's start to mix to noise. We don't need this now. All we need is the test tone and to set our values here. If I want to stick this into, and I was going to use K40, I'm going to use K20 because I'm going to drop everything by minus 20. If I drop this into K minus 20 and I switch on the MDA test tone, watch what happens in terms of our values. And you see how they vary because I'm using a K minus 20 scale here already. So here I've already allocated 20 dB of headroom. If this wasn't pink noise and it was a sine wave, we'd be hitting 0. So here I've given 20 dBs of headroom. In other words, I've said 0 is at minus 20 dB. I now want to mix to this because the fact that I've got 20 dB here on 0. Let's commence. The first thing to do, play your music. And to do that and hear your music, I need to have through on. If you have it off, all you'll hear is the pink noise. If you watch the video on mixing to pink noise, the idea is we switch on the pink noise. I've selected minus 20. If I go to 0 here, this will read 0 now, and this should read plus 20. And the reason it's doing plus 20 is because of the scale I've selected, which is minus 20. I'm now 20 dBs over. Makes perfect sense to set this at -20, so we're calibrating to 0 there and -20 here. And now, because we've got through on, we can actually play these sounds and hear them. Okay, I've muted everything, and you can just about hear the pink noise. What I'm going to do is bring it up a touch, because I want to hear it a bit more. So what's the idea? The idea is now, because we're using pink noise, if I were to start, say, with the kick, I can hear the kick above the noise. So the idea is to reduce the kick sound so that we can barely hear it under the noise. I could bring the fader down here, and that's about right. But what we want to do is have a fader up mix. So let's keep the fader up. Now, let me bring in the VUMT and use that purely as, and because I'm on a mono channel, I'll use the solo. I'll use this knob here. I'm really not that bothered about the values here, but if I want to be anal and keep my eye on the meter, well, why not pick the same values as we did here? So now I control the gain of this channel with this knob. That's perfect. Absolutely gorgeous. Because now, if I want to make fine adjustments, the travel on my fader now works in fine-tune mode. Let's get on to the next one. This time, actually, let me not even use an insert and use from the racks here where it says pre-filter gain phase. I now have this section here. So I have my own trim knob on the channel. Perfect. I can just about hear that. And what we want to do is each time we switch a sound on, you want to mute the sound before it. I'm going to use the trim knob here. I can't be bothered with messing about with other things. Just be aware that with certain sounds like basses, you're going to have to drop them even further in your mix once you've done the noise mix. And with sounds that are high frequency, remember, they're going to cut through pink noise much more easily. So the perceived loudness is going to be more than if it was at the mid-range. So try and pull back on your gain values. On this one, let's use something else for a change. Why not use my man Antoni's wonderful products? And let's see, it's a snare. So why not use the mono here? Because I'm going to use this as the trim knob. Next one. Next one. Over there. Nice little crash there. See, I just instinctively know when I need to bring it down by. It's about the same value. Bass. I can just about hear it. But I'm going to pull back even further there. Why? Because I know I'm going to apply compression, EQ, and all the funky little things that I like to do with low-end sounds. Crash bass, rap verse. Okay.
Yeah. Easy.
Ha! I know you're getting bored, but I don't really care. More rap. This one I reckon about 10. First, let's switch off our test tone. And now, switch on all our solos. Now look at all our faders. They're still sitting at 0. Let's bring that up so you can hear it. And magically, you have a mix. No effects, no dynamics yet, nothing. And already you've got this lovely balanced mix.
Yeah.
Gorgeous. And on the K20 scale, Look how much headroom we've got. Look at this. Absolutely beautiful. Let's go to our master bus. Now what I'll do is, because we've got this varying amount of audio here, as a final little thingy-jiggy-me-me. Yes, that is a language. So don't get in my face. I know it's going to take a little bit of while, but that's what we're here for. Let's first, K20, AES17, ppm meter. I'm using this as the K scale reference, BX meter, loudness meter, and let's play now.
Yeah. Easy.
Wonderful. Look at this.
Move with it. Your boy Shroom.
And our readings here. And because I'm in standard mode, I'm in digital mode. I DBFS. Let's go to K20.
Best kept secret.
Eerie, isn't it? Perfect alignment. Okay, so we've now got this mix, which sounds lovely, with just under 16 dB of headroom, because I know that we're going to have other instruments that are coming in later. But this is what I want you to look at now. And this is how we use loudness meters, bearing in mind that I've just done a basic mix. We start here. So let me put my locator there. And I know the vocals are going to come in later. So I want this quiet passage, or quieter, because we've only got drums and bits playing, to be involved, so you can see how the loudness range, which is our dynamic range, changes over time. And what's important for me is this. I know that the gating function on this will probably be set to about -10 LU. I can't be sure. But if it is, then we're going to get a far truer reading over the program integration. Let's play it. Press reset. So everything's flatline now, and play it. Right now, look at our integrated loudness. But what happens when the rap comes in and the other sounds? You'll start seeing it climb and climb and climb.
Easy.
Remember, this is averaging everything.
Boy Shroom. Yo. Brown paper
When I
bag,
get here,
brandy to keep
I'll
the
hit
throat
stop
warm.
and we'll read
On
the
block,
values.
on the clock with the product, I'm there for 'em.
You can see my
Best
true
kept
peak,
secret.
-15.7, -15.8. Remember, this one's on the K20 scale. So let's look at this now. Our integrated loudness is currently at -30.7, which is absolutely perfect. My true peak is sitting at -15. But remember, there's other instruments to come in, so always accommodate for that. Loudness, short term, -28.4. So this is the calculation over 3 seconds. And this one is very important to me when I have things like drums, hi-hats, because it gives me the 400 millisecond integration time, so I can see all the transients. And this is integrated over a longer instance, as this is integrated over even longer. Again, covered in the last video. So now I know I've got 6 dB of dynamic range in that material. Not bad. My true peak is -15.7. Not bad. And my integrated loudness, which is my program integration loudness, is -30.7. Absolutely gorgeous. That's how you use a loudness meter.